Imagine a blue sky sprinkled with jelly cubes instead of clouds. Close your eyes and picture cotton candy clouds bursting with strawberry flavor. Then, as the wind blows, tiny drops of sweet rain fall on your tongue. Could this really happen? Let's float into a wild but scientific thought experiment. First, we must know how ordinary clouds work. Warm air rises from Earth's surface carrying invisible water vapor. As it climbs, the air cools and the vapor clings to tiny specks in the sky, dust, salt, or smoke. These bits are called cloud condensation nuclei. Around each nucleus, a microscopic water droplet forms. Millions of droplets together make the white puffy clouds we see. Now, swap those ordinary nuclei with sugar crystals. In theory, if we sprayed superfine sugar particles into the updraft, each crystal could act as a seed. But sugar doesn't evaporate like water, it stays solid instead of true sugar mist. We need microscopic granules, about 1 micron wide, thousands of times smaller than a grain of sand. We loft them in tiny balloons or rockets, releasing a sugary aerosol high above. Up there, temperatures drop well below freezing. Will sugar freeze? No, sugar is already solid, so it won't break into ice the way water does. But when water vapor meets a sugar seed, the droplet forming around it dissolves some sugar. The droplet becomes a sweet micro-solution. In a real cloud, each droplet measures only a few micrometers across, too small to taste. To grow a raindrop, you need coalescence, droplets bumping and merging, until they weigh enough to fall. In our candy cloud, sweet droplets collide and form larger drops. By the time a raindrop is 2 millimeters wide, it contains millions of original microdroplets. If enough sugar dissolves along the way, that final drop might be slightly sweet. But how much sugar per drop? A single 2 millimeter drop weighs about 4 milligrams. Humans sense sweetness at roughly 1% sugar by mass in water. So each raindrop would need 40 micrograms of sugar. Multiply that by the trillions of raindrops in a light shower, and suddenly we need tons of sugar scattered across the sky. Beyond logistics, there are chemical puzzles. At cold temperatures, sugar solubility drops. Some crystals might remain undissolved, and ice could coat seed, blocking droplet growth. Thus, dumping huge sugar loads into the atmosphere could feed airborne microbes or create sticky fallout on forests and cities. Still, this candy rain idea reveals real atmospheric science gems. It highlights the magic of cloud condensation nuclei, the dance of phase changes, and how tiny particles steal weather. It shows you don't need to actually feed a sky full of sugar to learn about droplet growth, nucleation, or cloud microphysics. Next time you watch clouds drift by, imagine them made of jelly seeds and micro sugar droplets. Let your mind wander to sweet storms and candy showers. Even the wildest idea can spark wonder and real science when curiosity takes flight.